All right, so today we're going to talk about actually graphing a system of equations. And we're going to start off with just a little bit of review from last time. So, system of equations is two or more equations with the same variables. So, two linear equations, same variables. That constitutes a system of equations. So, graphically, the point xy is where the two lines intersect, also known as our solution if there is one solution. And then algebraically, the point xy is the point that makes both equations true. So it's a solution for both individual equations, and that makes our solution for the system of equations. So intersecting lines look something like this. Two lines that cross, of course, with our solution in the middle, and we would say that solution is point xy with whatever values are in there. Parallel lines, they run alongside each other. They never intersect. So our solution would be no solution. And then we would also have the possibility of being the same line. And that's just going to show up as one line, and that would be infinitely many solutions or infinite solutions. So solving systems by graphing, we have 3 steps. First step is to rewrite the equations in slope-intercept form. Which we can also solve them in standard form if you know how to do that using the intercepts. That's perfectly acceptable. We will end up talking about that in our next video. But if you already know how to graph using intercepts, then you can also do that if you prefer to do it that way. Really, the big picture is that we want to graph the lines and, find our solution that way. So step 2, speaking of, we graph the lines. We don't just graph one of them, we graph both of them. And then our third step is to identify the solution. And I'm going to put a parentheses. Ooh, that was a subpar parentheses. Parentheses S here, just because there is that possibility of infinite solutions if we are graphing the same line. So we're going to leave that open as a possibility. Now, we're going to move into our first example. So we're going to go ahead and graph this. I'm just going to label each of these lines with the color I'm going to use. So for this first one, this y equals x minus 8, I'm going to use blue. And to graph these, we first graph our y-intercept, which is going to be the point at which it crosses the y-axis. So negative 8 on the y-axis would be 1, 2, 3, 4, 5, 8 would be right here. So that's going to be our first point. And then the next thing we look at is our slope, which our slope here is 1, even though they didn't put it there. So we go up 1, right 1, up 1, right 1, up 1, right 1, so on and so forth, or down 1, left 1, down 1, left 1. And then we're going to connect all of these points with a straight line. Now we're going to do the same thing for the green line. Our y-intercept on this line is going to be positive 1. So our first point is going to be on the y-axis at positive 1. And now our slope for this one is negative 2, which means we go down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, so on and so forth, forever and ever. And we can go the opposite. We can go left 1, up 2 as well. Now I'm going to do my best to draw a pretty straight line. Art, not my strong suit, but I think I did a pretty good job there. So now we've graphed both lines, and I'm just going to grab my red marker here, and I'm going to highlight this point where they intersect in red. And this point I see is 1, 2, 3 right, 1, 2, 3, 4, 5 down, which means this point is at +3, -5. So our solution to this would be +3, -5. Okay, so just to review, we graphed our lines and then we identified the solutions. Both of these equations were already written in slope-intercept form, so we didn't really have to do that step. Some of them we will have to do that for. So let's go ahead and let's look at our second example, which once again, I'm going to start off by highlighting the color that I'm going to use to graph each line. So let's start with our blue line. Our y-intercept is at 9, so our first point is going to be on the y-axis at +9. And then our slope here is 1/2, so a rise of 1 and a run of 2. So up 1, right 2, and we're off the graph already. So I'm going to go down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2. And I'm going to attempt to connect those in a somewhat reasonable manner. Now we're going to move on to the green line. So our y-intercept here is +6, so we're going to go up 6. 1, 2, 3, 4, 5, 6. Going to put our point there. And our slope here is -1. We can draw that 1 in there because there's nothing in front of that x except for a negative sign, so that means it is -1. So for that, we would go down 1, right 1, down 1, right 1, down 1, right 1, so on and so forth. I'm going to go back the other way, up 1, left 2, up 1, left 2, up 1, left 2. And I'm going to connect these lines in as reasonable a manner as I can. All right, so we have our 2 lines graphed, so I'm going to switch over to my red marker, and I'm going to highlight the point where these intersect again. And I can see that that point is at -2, as in 2 to the left, and then +8, 8 up. All right, so that would be our solution there. Now, let's go ahead and scroll on down to our third example here. And our third example, we are not in slope-intercept form, which means we have to do a little bit of manipulation. So first equation, I'm going to put this in slope-intercept form first. So I'm just going to copy this down, -3x plus y equals 8. And so to put this in slope-intercept form, I need it in y equals mx plus b form. So I need the y by itself on the left-hand side. So I need to get rid of this -3x. And to do that, I'm going to add 3x to both sides. Now I have the y by itself on this left-hand side. So I just need to do a little bit of rearranging. And my rearranging, I'm just going to flip where the 3x and the 8 are. Since they're both positive, I can do that with no issue. But just a reminder, if they're not both positive, it's important to look to the left of whichever term you're moving and keep that sign with that term. I'm just going to label this blue real quick. Now let's go ahead and solve our second equation, put that into slope-intercept form. So we start off with -x plus y equals -2. So once again, I want to solve for y, so I want to get rid of everything other than y on this left-hand side. So I need to get rid of a -x. To do that, I need to add x to both sides, and I'm left with y equals -2 plus x, but I'm not done yet because it's not in y equals mx plus b format yet. I need the x to be listed first, so I need to switch these terms around. Now, I need to be mindful there's a positive sign in front of the x, which means that x is positive, but there is a negative in front of the 2, which means the 2 is negative, so I need it to be y equals +x. I'm not going to write the positive sign in there. You can if you'd like. -2. Since there's that negative sign in front of the 2, it needs to be -2. All right, now I'm going to label this one green, and we're going to get to graphing. So I'm going to start by graphing my blue line, which starts off at a y-intercept of 8. So I'm going to draw that in there on the y-axis, up 8. And my slope is 3. So right 1, up 3, and I'm off the graph. So I'm going to go down 1, or I'm going to go left 1, down 3, left 1, down 3, left 1, down 3, all the way. And I like to put all the points in just to be precise, because I know drawing a straight line is not going to be my specialty. If you have a ruler or something and you feel really confident, you can just put a couple points in. But I'm not that confident in my ability to draw straight lines. So that's why I put so many points in. Now, my second equation, I have a y-intercept of -2. So my first point is going to be on the y-axis at -2. And I have a slope of 1. So I'm going to go up 1, right 1, up 1, right 1, up 1, right 1. I'm going to go down 1, left 1, because I know that's where it's going to end up crossing this line. So now I'm going to connect these points in as reasonable of a manner as I can. Now I'm going to grab my red marker and I'm going to highlight this point where they intersect. And that point appears to be at -5, -7. All right, let's do one more example together, and we'll turn it over to you. Let's do number 5, because I think number 5 is a great example. So, good news is one of our equations is in slope-intercept form already, and that's our green equation. Now, let's get our blue equation in slope-intercept form now, and then we'll worry about graphing. So I have x plus 3y equals -15. And once again, I need this y all by itself on the left. So I'm going to get rid of this positive x by subtracting x from both sides. And I see we have a -15 and a -x now on the right. So I'm just going to go ahead and flip those just for ease and comfort. So I'm left with 3y equals -x minus 15. Now, we have our y by itself on the left, but we do have that coefficient in front of it, and that is not okay. We don't want that coefficient, so I'm going to divide by 3, which means I need to divide each term by 3. So I'm left with y equals 1/3, -1/3 x minus 15 divided by 3 would be 5. So I'm left with y equals -1/3 x minus 5. So let's go ahead and graph that one first. So my first point is going to be on the y-axis, and it's going to be at -5 on the y-axis for my y-intercept. And now my slope is -1/3. So I need to go a rise of -1, so down 1, right 3. Down 1, right 3, down 1, right 3. I'm going to go up 1, left 3, just because I don't know exactly where this is going to cross, so I want to be thorough, make my line all pretty and happy and delightful. Now my green line, y equals -7, but we don't have an x. So since we don't have an x, I know that this should be saying y equals 0x minus 7. So I could write it that way if I really wanted to, but it seems a little bit silly to me. So the cool thing about this line is y equals -7. So I know I'm going to cross the y-axis at -7. And I know y equals -7. It doesn't matter what my x value is, because y is always going to equal -7. So my line is going to go straight right and left along this y equals -7 line. So it's going to be a horizontal line. Now I'm going to choose my red marker again. I'm just going to highlight this point where they intersect just to make it a little bit more clear. And my final point is going to end up being 1, 2, 3, 4, 5, 6 right, and 1, 2, 3, 4, 5, 6, 7 down, Was it 6 right? Yeah, 6 right, and -7 down. Like how one of my equations is y equals -7, yet I still counted that that -7 down, even though we know the y coordinate has to be -7 because one of those lines is y equals -7, of course. So that is how you graph two linear equations and solve those linear equations. Let me know if you have any questions. Have a great